Hi, I am Syed. In the previous video, we were doing few problems based on homogeneous PDE of one independent variable. We'll try to continue with few more problems in this video.
We'll move on to the next question. Solve dou square z by dou x square is equals to a square z. Given that when x is equals to 0, dou z by dou x will be equals to a times of sine of y, and dou z by dou y is equals to 0. So if you try to observe over here, x is the independent variable, therefore it contains only one independent variable. You can write it in the form of ODE. So since the PDE has only one independent variable, only one independent variable, that is x, therefore we express the PDE as ODE. We express partial differential equation as ordinary differential equation. Therefore, the differential equation becomes d square z by dx square is equals to a square times of z. So you bring this a square z on the left hand side, it becomes d square z by dx square. So this positive will become negative, minus a square z is equals to 0. If you write in the form of the operator, it is d square minus of a square times of z is taken common outside, that will be equals to 0. So if you write down the auxiliary equation, it is m square minus a square is equals to 0. So it is in the form of a square minus b square. So you can write it as a plus b into a minus of b form. Or if you try to equate m plus a as 0 and m minus a to be equals to 0. So the value of m will be equals to, plus a goes on the other side, it becomes minus of a, m will be minus a goes on the other side, it becomes plus a. So we have got this as the root. So here the value of d that is there, the operator d is nothing but d by dx form. Independent variable over here is x. Therefore the solution should also be in the form of x e power of minus of ax plus c2 e power of ax, right? So one is a negative a, another is positive a. Good. So that's the solution we have. Z is equals to c1 e power of minus of ax plus c2 e power of plus ax. Now we'll try to write down the solution of PDE. So the solution of PDE will be z is equals to, we have to replace this c1 by the function, because here x is the variable. We have to write down this constant c1 as a function of y, f of y into e power of minus of ax, plus c2 will be replaced as g of y into e power of ax. So we have got the value of z. Now I need to find out these two values, f of y and g of y. So let us take this as equation number 1. So to find out these two values, you have to go back to the conditions given in the question. So what is the first condition given? X is 0, and both the conditions which are given, one condition is given as dou z by dou x, another condition is given as dou z by dou y, which means for z there is no condition. So I cannot use the condition directly. So therefore first let me differentiate this z with respect to x as well as with respect to y to use that conditions. Those two conditions if you want to use, I have to differentiate this one. So let us try to differentiate this equation number 1 partially with respect to x. Partially with respect to x. So we'll try to differentiate this with respect to x. So we'll be getting the value as dou z by dou x is equals to I am differentiating with respect to x, therefore f of y will be constant as it is. Differentiation of e power of minus of ax will be e power of minus of ax into differentiation of minus ax will be minus of a. So I'll write it over here plus g of y as it is. Differentiation of e power of ax will be e power of ax and differentiation of ax will be a. Further I have to differentiate this 1 partially with respect to y. So I'll be getting the value to be equals to dou z by dou y is equals to. So we'll go back to equation number 1, differentiate with respect to y, which means f of y derivative will be f dash of y. So it will be f dash of y into e power of minus ax is a constant, keep that value as it is, plus g of y. G of y differentiation will be g dash of y. G dash of y into e power of ax is a constant as it is. So these are the two equations we have. Now I can use the conditions. So let me take this as equation number 2 and let me take this as equation number 3. So we have got these two equations given the first condition. So x is 0 and dou z by dou x. Dou z by dou x value is a sine y. A sine of y. So dou z by dou x is in equation number 2. So we'll go for equation 2. Equation number 2 implies. So equation number 2 will be equals to dou z by dou x is a sine of y. A sine of y is equals to minus a f of y into e power of x value is 0 plus a into g of y into e power of x value is 0. We know that e power of 0 will be 1. So if I take a as common, in these two terms a is common. So if you take a common, I will be left out with minus f of y plus g of y. However, this left hand side will remain as it is. This a and a will cancel out. I will just be left out with sine of y is equals to. So you have this value minus f of y plus g of y. So let me keep this equation as it is, equation number say 4. So one condition has been used. Now go for the second condition. Given the value of x is equals to 0 and one more value that is given is dou z by dou y. 0, read the question properly. So these are the two values that are given. So dou z by dou y is in equation number 3. So go back to equation number 3. So equation 3 implies. Equation number 3 implies. So dou z by dou y will be 0 is equals to. It is f dash of y into e power of x value will be 0 plus you have g dash of y, g dash of y into e power of x value is 0. But we know the value of e power of 0 is 1. So you'll just be getting the value to be equals to f dash of y plus g dash of y. But I cannot solve this equation 4 with this particular equation because here you have f of y and g of y, but in this case you are getting f dash and g dash. You have to get this f dash and g dash in the form of f of y and g of y. So therefore what I'll try to do is I'll try to integrate this one. So integrate with respect to y. So if I try to integrate it, so whenever I'm integrating, I need to include the constant of integration. So it is better you can write down this way. This equation can be written as f dash of y plus g dash of y is equals to 0. So I'm integrating this one. It is integral of f dash of y into dy plus integral of into dy Let me take the constant of integration to be some k. Now if you try to integrate, f dash value will be f of y plus g dash value will be g of y is equals to, I have got the value as k. So that's the expression. Now you can see equation 4 is having f of y and g of y. Now this equation, I can take this as equation number 5. So we'll try to solve these two equations. So solve 4 and 5. Solving 4 and 5. So I'll write minus f of y plus g of y is equals to sin y. I have written sin y on the right hand side. Then equation number 5 will be f of y plus g of y is equals to, you have k. So now directly you can just cancel out this plus f of y and minus f of y. You will be just left out with g of y plus g of y will be 2 times of g of y is equals to, because you are adding it, you'll be getting the value as sine of y plus k, right? Sine of y plus k, or the value of g of y will be equals to. So you can just cross multiply. I'll first write down the constant k, then I'll write down the trigonometric function sine y. So whole divided by, I'm cross multiplying this 2 on the other side, will be getting divided by 2. So I have got the first value g of y. So if you want to once again find out, either you can 4 and 5 and then get the value of f of y, or you just plug in this g of y back in any one of these equation, either equation 4 or equation 5, and get the solution. We will substitute this value back over here in equation number 5. So substitute g of y in equation number 5. So you have f of y plus g of y. So g of y is this particular value, k plus sine of y whole divided by 2 is equals to f of y plus g of y is equals to k is there. This is your equation number 5. I'll take this on the right hand side. You will be getting f of y to be equals to k value as it is. Send this positive on the other side, becomes minus of k plus sine of y divided by 2. This will be equals to, if you want you can take the LCM as 2. So if you take the LCM as 2, just cross multiply. 2 times of k will be 2k minus of k. The minus sign has to be multiplied inside. Minus of plus will be minus sine of y. So further if you try to simplify this one, 2k minus of k will be k minus this sine of y. It is whole divided by 2. So we have got the value of f of y. So just substitute these values of f of y and g of y back in equation number 1. So your equation number 1 will be z is equals to f of y is k minus sine of y divided by 2 into e power of minus of ax plus g of y. G of y value is k plus this one, k plus sine y. G of y will be k plus sine of y divided by 2 times of e power of ax. Half is common outside, so can take half common outside and try to multiply this k times of e power of minus of x. So I'll write down here, just divide each of the term by 2. If I take say half common outside, what will be left out here? K e power of minus of ax. Alright, just taking half common outside, I'll write down this term, k is multiplied by e power of minus. Similarly, this plus k you multiply by e power of ax. So we'll be getting plus k e power of ax. That is one term. Then remaining you are having minus sine y e power of minus of ax. Here sine y e power of ax. So suppose if I take sine of y common outside. Alright, sine of y if I take common outside, what will be left out here? Minus e power of minus ax divided by 2, right? Or divided by 2 also, if you want you can take common, divided by 2. And first I'll write the positive value here. e power of ax. This sin y divided by 2 is already taken common outside, that is multiplied by e power of ax. Here sin y divided by 2 is already taken common outside. You are having this negative sign minus e power of minus of ax. So here you can take k common outside and write down the expression to be equals to e power of, first I'll write e power of plus ax plus, I'll write down this value as e power of minus of ax divided by 2, and plus here sine of y is common outside. You can write this value to be e power of ax minus e power of minus of ax divided by 2. But we know this value, its value is nothing but cos hx, or cos h. In place of x you are having ax. Here you have sine of y, this value is nothing but sine h ax. So that is the required solution. That's all I have for today. Thank you.